Assalamualaikum warahmatullahi wabarakatuh. My name is Udia Matunur binti Muhammad Baharudin, and my group members are Nabila Numansyara, Nur Kamilia Afrina, and Nur Anis Farhana. Today we are going to present about biomarkers in food toxicology. Foodborne disease, chemical hazard in foods, food additive, residues of pesticide, veterinary drugs, and environmental contaminants and genetic modification are the main causes of most food issues. In research from Abdul Muttalib et al. 2015 reported that incidence rates in France were found to be 1,210 per 100,000 population, in the United Kingdom to be 2,600, and in Australia and the US to be more than 25,000 cases per 100,000 population. In comparison with those countries, toxicology cases in Malaysia are lower since more cases are unreported and before it is put before the authority as a sequence of events must be dealt with. Referring to WHO 2020, an estimated 1,600 million, roughly 1 out of every 10 people worldwide, get sick due to the ingestion of contaminated food, and 420,000 die each year, resulting in the loss of 33 million healthy life years. According to Hirschman 2021, there were approximately 16.6 thousand food poisoning cases reported in Malaysia in 2019. However, as we passed the 1-year point in pandemic, COVID-19 seemed to have dramatically impacted reported food toxicity cases and outbreaks. In 2019, this decreased to 8,756, but almost half the total number of notifications in 2020 went down to 4,782. This is based on the collected data through notification of infectious disease reports from week 1 to 51 of 2020. The report showed that in 2018, there were 10,910 statutory notifications of foodborne disease. In only 2 years, there is a 57% drop in the cases.
Next, I will continue with definition of food toxicology. Food toxicology is the nature, qualities, effect, and detection of hazardous compound in food as well as their disease manifestation in human. For biomarkers, biological markers refers to a large subset of medical signals that are objective indication of a patient's medical status that can be assessed correctly and reproducibly from outside of patient. It can be defined as any substance, structure, or activity that can be tested in body or its product that influence or predict the occurrence of outcome or illness as defined by the WHO in 2001. Next, biomarkers in food toxicology. Biomarkers must be represent the amount or proportion of toxicant, nutrient, or possible metabolite produced from them that absorb and affect physiological activities in specific tissue. As a result, biomarkers should be able to recognize as a specific hazard and estimate the health risk assessment by specifying the cause-effect link. Individual variability is an important aspect in this context. It needs aid in clarifying the inherent ability and degree of reaction that given dietary item, which called biomarkers of susceptibility. I will pass to the next presenter.
The first class is biomarkers of exposure. This can be utilized as part of exposure evaluations to determine potential hazard when exposure measure and health impacts occurs at the same time. And the exposure of human food chains. For example, the exposure of human food chain towards the dioxins. The biomarkers can be used to measure the current exposure of dioxin towards the human food chains or the food source until the degree that we should be concerned. Second classes is biomarkers of effect. Biomarkers of effect are defined as any measurable biochemical, physiologic, or other alterations within an organization that, depending on magnitude, can be recognized as an established or potential health impairment or disease. Food toxicologists use several ways to deriving regulatory level health for health effect And this is the example for biomarkers of effect. And the thing that usually used are like BMD, Noel, or Lowell. The third classes is biomarkers of susceptibility. This is defined as the markers of an organism's intrinsic traits that make it more vulnerable to impacts of chemical exposure. This can assist in determining which sensitive are more vulnerable, as well as the critical times when exposure are most harmful. For example, the use in the food allergy or food hypersensitivity. That's all. Thank you.
I'm going to present about the usability of biomarkers in food toxicology. There are three usability of biomarkers in food toxicology, which are: first is accurate exposure estimation is a critical and especially difficult step in risk assessment. Extrapolation to external exposure is possible once the relationship between blood, urine, or tissue biomarkers and internal concentration of the compound of interest is understood. Second is pharmacodynamic spatiotemporal models can be built on the knowledge of compound concentration in tissue. According to Walker 2017, that spatiotemporal models is built to assess the risk of exposed population at the landscape level. The model is a spatiotemporal exposure hazard based on the three factors, which are: first is tools of stochastic geometry. Second is a disperser kernel describing the dissemination of contaminants from polygon source. And third is an eco-toxicological equation describing the toxicokinetics and dynamics of contaminants in affected individuals. In legitimate case studies, parameters and parametric functions encountered in the model must be precisely specified in order to obtain realistic risk and impact measure, as well as accurate comparisons of landscape configuration. And lastly is biomarker-based exposure assessment provide a unique opportunity to more accurately assess consumer exposure to process-related contaminants in food, and thus better inform the risk assessment of the exposure to these contaminants. The overview briefly explains how and where the process contaminants develop, as well as their potential influence on human health. The present state of knowledge on urine, blood, and tissue biomarkers for each of these contaminants is then outlined, and empirical models are described when available. In conclusion, exposure assessment is a critical component of the risk assessment paradigm, but it frequently presents a variety of obstacles and ambiguities. Food toxicology is advanced in many areas, but there are numerous challenges in predicting and translating the effects of specific toxicants in foods. Despite these obstacles, it is possible to conclude that biomarker-based exposure assessment offers a unique potential to more correctly estimate consumer exposure to process-related pollutants in foods and hence better inform risk assessment. That's all from us. Thank you.
The question regarding this topic. First question is, what is the factor that influence the interaction between host and food-driven components in taxonomy of biomarkers? This factor may be considered in the context of a food, diet compound, metabolite host, availability, and release of potential hazardous toxic compound from food matrix is a prerequisite to be biotransformed by gut microbiota or be directly absorbed. Information about host characteristics such as age, race, gender, health status, genetic susceptibility, and previous exposure to the same or other food-derived toxicants. The second question, what is the area in the measurement of toxicants and toxicity in food? What is the area in the measurement of toxicants and toxicity in food? There are two areas which are actual measurement to the effect of toxicant in different models ranging from in vitro biochemical system, cell-based in vitro system, and in vivo models to clinical settings, analyzing systemic or organ-specific toxicity and assessment, and predictions of potential toxicants in food.